Hello friends, welcome to Joy of Life. So another medium level problem number is 150. Very common problem, evaluate reverse Polish notation. So we need to evaluate the value of an arithmetic expression in reverse Polish notation. So the valid operators are plus, minus, multiplication, division. Each operand may be an integer or another expression. So each operand may be an integer, it can be an integer or there can be another expression. So some note as well over here. So let's look at them. Division between two integers should truncate towards 0. The given reverse Polish notation expression is always valid. That means the expression would always evaluate to a result and there won't be any divide by zero operation. So we don't need to bother about division by zero, which can cause an exception, right? So before we look into further details, so let us understand few of the expression types. So let's look at some of the expression types. So what are the different kind of expression that we might have? So let's take two numbers, say 5 plus 8, normal two numbers. This is called a infix. This is an infix notation, you can say. What does infix means? So the operator is in between the operands. So these are the operand, these are the two operands, and we have the uh, operator in between. So similarly, we have a this is a postfix notation. So as you can see, it says post means the operator is post the operand. So we have the operands first, then we have the operator. And similarly, there can be a prefix as well. So here what means your operand, your operator comes first, then the operands. So we have this prefix notation, which is also called a Polish notation. And here what we want is the reverse Polish notation. So the reverse of this one you can easily figure out is nothing but this. If you reverse this, what you get is 5, 8 and then plus, right? So this is called, so what happens is the operator is in the front, it goes to the back and the operand comes first. So this is called a reverse Polish notation. So we are going to get our inputs in this format. So over here you can see that we are getting a 2, 1 and a plus. So what happens is 2 and a 2, 1 and a plus will first evaluate it to 3. Then we have 3 3's star, which will evaluate to a 9. So this is our result over here, 9. And similarly we have some more examples down below. So here also you can see some of the other expressions. So we have 4, 13, 5, then followed by a division sign. So what happens is first we get a 4, then we get a 13, then we get a 5, and then we get a division. So once we get a division, we do a 13 divided by 5. So first we have a 13 divided by 5 plus 4. This is what happens when we uh, convert this to an infix notation. So you get a 2 from here and a 4 from here, which will result into a 6, which is our answer. So I am not going to do this for you. This is, you can say this is a task for you, and the explanation is given over here. But yeah, it follows the same approach that we have discussed earlier. Since it's very big, I'm not going to do it manually. So let's head over to the code. And as I always say that before you look at the solution, do give it a try yourself, and probably you will find a solution which is better than mine. And do resume the video once you get a solution, and then we can resume the video. It's always good for you to try it that way. So let's head over to the code and let me get this data that I have given over here into a sheet so that you can refer it at any point of time. So what I have done over here is I have got all the expressions for you, and this is the one that is of interest to us, and we are going to focus on this one for this problem. So what would be our approach? We'll see the approach over here in details, and we'll discuss all the possible scenarios. So let's get one of the example data from Leetcode and try to solve it. So I have got the input from the example, and as you can see here that the data is given to us is a array of string which they are calling as tokens, and we are going to traverse over the tokens and come up with the solution, the exact answer that they are looking for. So let's head over to the problem and see. So how we are going to solve this problem. So we have been given also to mention there are 5 operators that they have mentioned over here, right? That we want to consider. No, there are 4 of them: plus, minus, multiplication, and division. So here are the. So we need to address all 4 of them and nothing else. Modulus or percentage or whatever is not required. So we are just going to do for them. So how we are going to do this is we are going to use a stack, and we'll show you how stack will help us over here. So as you know that stack is a data structure that is a LIFO data structure. Last in, first out. So the last element to go in comes out first, right? So what we are going to do is we are going to traverse this array from left to right, and as we get operands, so we are going to have separate actions for these special characters, and these are our 4 special characters. And apart from that, what we expect to be in these strings are nothing but integers. Okay, so once we get an integer, we push it to the stack. So let's draw a stack over here. So here we have the stack. So the first element, so the I, let's say, starts from 0, and we get a element which is 2. We push it to the stack. Okay, and then I increments to 1, and the next element we get is a 1, and we push it to the stack. Okay, and then I moves on. I moves to 3, and we get a plus over here. So it signifies a operator, right? So when we get an operator, what we are going to do is we are going to pop 2 elements out of the stack. So we are going to pop first and pop second, and we are going to apply the operator on that. So when we pop the first element first, we get a 1. When we pop this so 1 is removed from the stack, then we pop again, what we get is a 2, and this is also removed from the stack. And what we do is we put the operator in between it. So we do a 2 plus 1 and we get a result 3. And what we are going to do with this result is we are going to put this result back to the stack, right? So we just do the operation and put it back to the stack, and then I moves on. So I goes to 4, it gets a value of 3. So we put the value on the stack, and then I moves on to 5. And what we get when I moves on to 5, we get the operator star. So again we do the exact same thing that we have done earlier. Pop first and pop second. So when we pop first, what we get is the first element from the stack, which is this 3 we get. And then what we are going to do, pop the second element. So we get another 3 from the stack. And what we are going to do is we are going to apply the operator that is on the current index, and we get a 9. And what do we do to the 9? We put it back to the stack. So if you look carefully, 9 is the only element present in the stack. And just let me get some space here. Yeah. So what happens? I moves to 6, and this is the end of string, end of array. We don't have any more elements in the array. So the element that is there in the stack is my answer. We just return, say stack dot pop. What do we have here? We have a 9, and 9 is our answer, as you can see, right? So we have already got the answer that we are looking for, and let's do this for the other input that they have given us. So I have copied the same input again, the second input, into our sheet, and we are going to create the stack as we have done earlier. So let's create a stack, and let's get it done. So I have created the stack once again, and what we'll do is we'll start going from left to right as we have done on the earlier problem. So I starts with 0, and what we do is we get a value of 4, and since this is just a number, we are going to put this into the stack. And then I moves on, I moves to 1, and so I moves on to 1, and we get a value of 13. We push that into the stack, and I move on again, I moves to 2. So since we are not getting any operators, we will just be pushing it into the stack. So we get a 5. The value is pushed to the stack again. So I goes to 3, and we get a operator now. So we get the division sign over here. So as we have seen earlier as well, that what we do is we pop 2 elements from the stack. So we pop first, and we pop second. So when we pop the first element, what we get is a 5. We get the second element, we get a 13, and we do a division between them, right? We divide 13 by 5, and what we get is nothing but a 2. So our answer over here is a 2. And as we have popped, this value will go off from the stack, and we push this value back to the stack, right? And then what happens is I moves on. So I moves on to 4, and again back to back we see that there are operators, and we get a plus operator this time. And what we do the same thing. We pop the first, and we pop the second. So when I pop for the first time, what I get is a 2. So 2 is removed. Then I pop again, I get a 4. And the operator that I am currently at is a plus. So we get what we get is a 6. So what do? We put the 6 back into the stack. So what happens next is I goes to 5, and which is the end of array. So it goes out of bound of the array. So in that case, what we did the similar thing last time as well. We return the stack dot pop. So when we do a stack dot pop, what we get is the value at the top of the stack, which is a 6. And you can see here the result is a 6, and so 13 divided by 5 is performed first, and then 4 is added to the result. So we did something very similar over here. We did the 13 divided by 5, we got a 2, and then we did a 2 plus 4, and we got the result. So this is also popped. So what I'm going to do is we are going to since we have few of the operations to complete over here, we have four of the operators and we have to perform a operation for each one of them. What I'm going to do is I'm going to use the function take advantage of the functional interfaces in Java. We are going to use that and we are going to get things done. So for each of the string plus, minus, division and multiplication, we are going to keep a by function. So by function, what it does is, as the name suggests, the function takes two arguments and returns one argument. And here, since we are dealing with integer type, so I am going to use all three as an integer. So it will take two integer as input and return one integer as the output. So let's name them operators, and we are going to create a hash map. Okay, so what we are going to do is we are going to put in the operators dot, we are going to add to the map. So we have to map each of our operators, and the key is the operator, the plus sign as a string, and my value would be the by function. So what it does is it just returns the a plus b. For the sake of simplicity, I'm just doing it. So when I get this plus, I'm just going to call this by function to get my things done. Similarly, I'll do it for the other operator types as well. So four of the operators are mapped over here. And so what I'll do is now since my most of the thing is done, so I'm going to create a stack of integer as we have discussed and name that as stack. So I'm going to create a stack of integers, and what I'm going to do is I'm going to parse over the token, and what I'm going to do is if a token, so token is nothing but the inputs that you have seen over here. These are my tokens. In this input, these all are my tokens: 4, 13, 5, division and plus. So if what I can say is if so I have this map, right, operators. So if I can say that if my operators contains key of token, so if it is any of plus, minus, multiplication or division, I can just check it with the help of this. So if it is any of it, this will return a true. And if it is true, what we are going to do is, so let's say not operand but op1, we are going to do a stack dot pop. Similarly for operand 2, so we need to pop twice from the stack as we have seen on the try run. So once we get both the things out of the stack, what we are going to do, we are going to push them back to the stack after performing the operation, right? So what I can do is I can say operators dot get, and I can get it with the token, right? By function back. So it will give me the corresponding functions back. And what I am going to do is I am going to call this function. So how you call this function? You just basically call it using the apply method. So I'm going to pass operator operand 1 and 2. And this will, what it will do is it will call this method, appropriate method, get the return type and push it back to the stack. Otherwise, what we are going to do, so if it is not any, if this is not matching, right, then what are they? They are nothing but normal numbers. So I am just not going to do anything, but I'll just keep pushing them to the stack. So I'll be pushing them to the stack, but I have to keep in mind that I have to get it parsed because they are currently in string format. So I'll do a integer dot parseInt in order to convert them to integer and put it to the stack because our stack is of type integer. And when we are done, so we will be left with one item in our stack, and we are going to pop that, and that is nothing but the result of the entire operation that we just did. So let's run this and check. So my bad, this will be put, this is a map, not a list. So let's run it again. So you can see that it has been accepted. So let's do a submit and check it for a broader range of test cases. So this has to be operand 2 first, then the operand 1. Because you see that we are putting it in the reverse. So when we are putting the elements into the stack, what happens is if I put A and then B, when I take it out, B comes out first and then A. So the operator 2 has to be so let's say for example like 10 divided by 2. So what happens is we get 10 to division, right? So we put 10 first, then 2, and then the division. Then we get the division operator, right? So when we take out, 2 comes out first, so 2 will be over here and 10 will be over here. So if we do not reverse it over here, what will happen is we'll get the wrong answer. So operand 2 should be going first. So if operand 2 goes first, what happens is 10 divided by 2. Currently, since I have given it wrong, so it was happening 2 divided by 10, which is giving us the wrong answer. So let's try it out again after changing. So yeah, it has been accepted, and we can see that it's better than 40, faster than 40.94%. So you can think of some enhancement here and there, but during an interview, this is, I think, one of the most optimal solution that you can think and come up with. In interview, the most important thing is your approach towards the problem. And of course, you can think about optimization and other stuff later. And here also you can just think about some optimization, but yeah, I wanted to convey the concept to you, and I hope I was able to do it. Do let me know what you think about the video. Do give it a like. It will always motivate me a lot. And do share and subscribe if you haven't done so. Yeah, and thank you for watching it, and have a great day. See you soon again. Bye bye.